Hey friends, and welcome to the Adventures of Blink. I am of course Blink, and you can find me on GitHub right here. Now, before we go any further, I want to remind you, if you get something good out of today's episode, click the like button. That lets me know that my content hit the mark, and that feedback helps me build better content in the future. Additionally, I want to make sure that you remember to subscribe. If you subscribe, you're going to get updates to whatever future adventures happen. And in particular, that's important for something like this, where we're in the middle of a season, because you'll want to be able to catch the new episodes as they come out, the new adventures that follow along. So subscribe, join the party, and let's be part of building together. Today on the show, we're going to dig into a topic that's near and dear to my heart: automation. I've heard it said that the best software engineers are what they call productively lazy. That might sound like a contradiction at first, but it's easier to understand it if we rephrase it a little bit and just say automation obsessed. You see, a good engineer is lazy in the sense that they don't want to do busy work, but they're still going to get all that work done. They're productive. So if there's a way to automate that work, they'll do it. That's where they go. And that gives them the ability to forget about that one little thing that has to happen and focus on something else that's more valuable. So the question then arises, what should we automate? The answer, as far as I'm concerned, and what I seem to see in the DevOps community, comes down to a single word: toil. Toil we would define as repetitive manual work that doesn't add lasting value and scales as a service grows. We all have work like this in our lives. Tasks that are required to keep things operating, they keep the motor running, so to speak, but they're not really improving the product, and they're not directly helping our customers. The repetitive nature of toil makes it a prime target for automation, because if it's repetitive, then it's easy to script out what's going to happen. If we can make those things happen with minimal effort, we maximize the time we spend on other activities that create actual value. So let's take a look at some examples of toil. So the first example that pops into my head is compiling code. If I manually build my code into an executable, it takes time and attention to complete that task. And I might also miss a step, which introduces error into the process. If I'm in a hurry, I might skip over something by accident, and then I have to redo the whole thing, and that makes it even more painful to do. Automating the build steps means that my application gets built consistently, as well as freeing up my workstation to work on other tasks while that build's underway. I can offload that work to somewhere else and just get the results when they're ready. The next example I think of is security scans. There are tons of tools you can get to scan your code, whether it would be for supply chain issues like a Black Duck or code quality analysis like SonarQube. But scans can take a potentially long time to complete. And just like the build process, it would be better if we could do that without direct human interaction. Another example would be API documentation. Tools have existed for several years now that will accept your API code as an input and return developer docs to explain how to use the API. So if you have a need for this, building this directly into your process will save your developers a ton of time writing and explaining what they coded. And that leads us to another idea, which is other documentation. This seems to be a relatively new capability thanks to the explosion of large language models. But what if you automated all of your documentation by passing your code through an LLM to build the docs for you, or at least give you the first draft? And finally, and maybe most popularly, deployment itself could be the most popular use for developer automation. In the olden days, we had to manually copy our compiled code onto a server, or multiple servers if we were running something in a clustered environment, and go through this arduous configuration process to get it working, making sure all the right config files made it to all the right servers, making sure that everything lined up just the way it was supposed to. And there were always weird quirks that we had to work through because we didn't keep our environments in sync. Automating this, making it all completely touch-free, is a core competency of DevOps. It should be easy to get your code into production. Now you might be asking, what in the world does this have to do with Git? We're talking about a whole lot of other tools and processes. These are not things that live inside of Git. Well, our code lives inside of Git, right? And all of these things have code as an input. So it makes sense that if we were going to automate all this work, we would want to start somewhere close to the code. But Git doesn't support automation as a protocol, right? It's just here for source control. This feature is something you'll find in the web tools. And so over the next 2 weeks, we're going to examine some of the automation capabilities that are built into GitHub and GitLab. Today we're going to start with GitHub and explore the Actions feature a little bit. Now, if you've been adventuring with me for a while, you might remember this from Season 2, Episode 5. I'll leave a link. We covered this feature back then, but we covered it from the perspective of unit testing. So we built some unit tests, and then we made it so that every time we pushed into the repository, the unit tests were run to ensure that we had, pushed up good code that wasn't broken. I walked through that in that detail back then, but today's look at Actions, we're going to look at a wider range of activities because there's a lot more than unit tests that you can actually do. All right, so let's take a look at how to create a GitHub action from the interface. First thing you do in your repository is you go over to the Actions tab, and you'll see if you scroll down here, there are a ton of pre-configured ways to use GitHub Actions. But in our case, what we're actually going to do is just create a simple workflow. We're going to start from scratch. GitHub is going to provide a template for our action, and it's got most of what we need pre-configured. Because we didn't pick anything that's more complicated out of the templates list. This is going to be bare bones, but it's enough to kind of help you get started with the idea. So first, you need a name for your workflow. And this is the way that it's going to be identified in the interface so that when you go back to the Actions tab and you watch to see when actions have run, you can see it by name. And then the next thing you see is this on variable on line 6. On is how you know when a workflow is going to run. It's going to happen either on push or on pull request. Those are generally the two ways that you can do this. The third you see down there is actually workflow dispatch, which allows you to run it manually from the Actions tab. It'll give you a button that says you click here in order to make this happen. So those are your three basic options, but most of the time we see either a push or a pull request. Now, you probably won't want to necessarily run it in both cases. You'll pick one or the other. So it's giving you options here and then letting you sort of decide what to do with it. Now, the reason that it's letting you decide that is because you won't always want things to run every single time anything happens. So there are some cases where you want to do it when code is pushed, such as a deploy. So when we successfully push the code into a certain branch, then we should deploy the code to whatever system it's supposed to be deployed on. Things like that. But the other case, the pull request, might be in the case of like a security scan situation. Those security scans we want to run at the time the pull request is created, because what we want to do is use that as feedback to the pull request reviewer. So the idea behind a PR is, of course, that I have written some code and I've made some changes and I'm pushing it up and I'm asking for permission to merge it. So it's giving my team the opportunity to give me feedback on what I've done. Did I write good code? Did I forget something? Did I think through all the scenarios that should be handled by this code? All that kind of stuff. And so doing it on pull request actually causes it so that when the PR is created, it kicks off these actions runs. And that way, that information can then be used to decide whether the PR is valid or not. So if one of these workflows fails, you can actually fail the PR, and it prevents it from being merged until it's been able to process. So you have to keep adding commits in order to get the test to pass. Another good case for that would, of course, be unit tests. Just the idea that I have to keep coding until my tests pass. And the only way to know that is to have the workflow run it prior to actually pushing it into wherever I'm supposed to push it to. So if you force everything to run through a pull request, then you have the ability to test things out before you do the merge, which is really valuable as a developer. So the next thing that we're going to look at in our actions workflow is called jobs. And a workflow is made up of multiple jobs. These are sort of the building blocks for how you deliver code or deliver whatever it is you're going to do in your GitHub action. So a job has a name, and on line 17 we can see here this one's named build. Now you could replace that word with whatever you like and call the job anything else that you like. But in this case, they just picked build as sort of the example. The first line inside of the build is a runs on. Now this talks about GitHub runners. Runners are sort of like little Docker containers, and I use that term loosely. I don't know if they actually run them on Docker. I know it's possible to create Docker containers of your own custom runners. For instance, if you're doing GitHub on premises instead of in the cloud. But GitHub runners are sort of these containerized build units that will go off. They have certain software installed on the runner that allows it to do whatever task is needed. So in this case, we're using an Ubuntu latest runner, and this just means we're going to be running this on a Linux server. So GitHub spins up a little bitty Linux server for you in a container and gives you the opportunity to use it to run whatever things you want in your steps. So everything in this job is going to run on that container. That takes us to our next part, which is called steps. Steps are the individual actions that are taken within the job. So as you think about the flow of this, you have a workflow at the top layer, which represents the entire GitHub Actions, like this is the unit of work we're doing. You might think of that as deliver the code to production. And so in order to deliver the code to production, we're going to have multiple jobs. There's one job that's going to check the code out of Git and put it in the runner where it can and start the process. There might be another process that runs a linter. If you use any sort of code quality tools to validate that people have written the code well and followed your naming conventions and things like that. So you might have a job in there that runs the lint. You might have a job in there to do security scans or to do unit tests or even to do things like integration tests. You might actually spin up the code in your runner and get it to work so that you can run integration tests to validate that part A talks to part B successfully. So all of those become jobs. Now the individual steps inside of a job are the individual commands. So in order to run the linter, you probably have to, you have to run some command line that says run this against whatever files. If there's any sort of exclusions for certain folders that don't get linted, then you would want to have that incorporated into it. In your steps, you might have comments, and you can actually see there's an example of this right here where the script runs an echo of hello world. So you might use that to document so that as someone reads over the log of what's happening in your GitHub action, they get the ability to see like what step you got to and what things happened. You can print out the output of certain commands to know whether something ran successfully or whatever, just to give you feedback on how your pipeline is running. So let's see what we could do with this. Obviously, this repository doesn't actually have any code in it, but we could sort of set this up to give you an idea for the things you might see. So let's imagine we were running a Python application, right? And so we were going to do a simple install the dependencies and run the tests kind of operation. So what we would do is we have our job. We're going to call it build, and we're going to do runs on Ubuntu's fine. We'll use that. So down in the steps, the first thing we're going to do is check out the repository. And so you can see here they have the uses that explains that. But we're going to actually name the step just to make it easier to work with this. So we're going to come in here and do name, and we're going to do checkout repository. And so now when we run the GitHub action, the step will be named checkout repository. Pretty print, easy to read. We understand what's going on there. So after we've checked out the repository, what's the next step you might do? Well, let's remove this one-line script, and what we're going to do instead is, set up Python. So in order to use Python, we're actually going to grab a Python runner to handle this. And we're going to do the uses command and actions set up Python. And I think the latest is like v5. I haven't kept up, but I think we're probably good there. And so then the next thing we have to do, because Python has some other needs, we have to use a with, and we're going to do Python version, because we have to tell it what version of Python we want this to run on. And so we're going to do 3.12. Right, and so there you go. That's how you would create a Python runner that gives you the ability to use Python inside of it. All right, now I'm going to get rid of this run a multi-line script example down here, and we're just going to do install dependencies. And if you have ever run Python stuff before or hung out with us here on the Adventures of Blink in the past, you'll know that installing dependencies is a pip install -r, and then we look for the requirements.txt. And so that would be the single command you would run on your CLI. Instead, you're going to tell GitHub Actions to run it inside this runner so that it can operate for you. And then the very last thing we're going to do, we'll need to build one more step into this job. And we're going to say the name is run tests. And for this, we're going to do run. And of course, I'm a fan of PyTest just because it's nice and easy to work with. And there you go. You've actually created a GitHub action that's going to spin up a GitHub runner using Linux, and it's going to install Python, and then it's going to make sure we're using Python 3.12, and then it's going to install the dependencies of our app and run the tests, all in a single action. And so what we would do instead of calling this build, we would probably call this run PyTest or something like that. And so that way you've got a specific name that can be given to it. And instead of blank.yaml, we'll call this by the same name. We'll do run pytest.yaml. And then we can commit our changes. And there we go. So you'll notice this creates a commit. Now, where did that commit go? Well, if we go back to our season 3, here's the overall repository, and you can see right here we've created a .github folder. Now, inside of .github before, we only had issue template, and we talked about GitHub templates as a way to make things easy in your pull request to make sure you're gathering the right information or getting bug reports or whatever. But now there's a workflows folder. And so inside of the workflows folder, we now have our actions. This is where all of our actions are going to live, inside of workflows. And so you'll just get this list of things. It's important that you pick out a good naming convention for yourself just to be able to find things easily. And so you can see the example here. Actually, I probably need to do some more edits to make this work the way that we would want, which is I need to pull things out of the on. So in this case, we're only going to run them on main. And so let's just stay with that. We'll keep this nice and easy. Now, do I want it to happen on the push or do I want it to happen on a pull request? Well, in this case, I would want to make it work on the pull request. And the reason is because I'm running unit tests. That's what PyTest is built for, right? And so I want my unit tests to run when I create a PR to main. So I can go build things in my own branch, and that's fine. I can do all sorts of work out there, and that's not going to create any problems. But at the moment I create a PR and say, I want to push this into main, I want to merge what I've changed into main and make it part of the actual, releasable software, then I should be running my unit tests to validate that they've successfully, completed, that I haven't broken anything. So that's the way that we would set that up. And I'm going to just call this run PyTest up here as well. And I probably ought to name it the same. I don't think it matters. I don't think it's going to break anything for me not to. But keeping the name the same everywhere makes it consistent, and you can sort of understand better, what's going on and how it's connected to the overall idea. So there's my update for that. And so now I have a GitHub action. Now, you'll see that the workflow actually tried to run already. And the reason is because at the moment that I created it, I committed it to the code. Once it's committed to the code, it now has rules for when it has to run, and it's going to kick itself off. So it ran and failed, and we'll just take a quick look at what that looks like. I'm not actually going to get this to succeed because that would require me to go behind the scenes and write a bunch of unit tests and write some code for it to run against. And I'd rather not go through all that just to demonstrate actions. But here you can see it actually tried to run. And so I can click on it and I'll see, you remember we named our steps. So check out repository and set up Python and install dependencies and run tests. There we go. And so it failed when it tried to install the dependencies because this repository doesn't have a requirements file. And that's perfectly okay. That's kind of the expected behavior. So if you set these actions up ahead of time, you can actually start coaching yourself on what it is you want your code to do in the long run. So if I were just building a project from scratch here, I might set up a thing and say, okay, I know I'm building in Python, so I'm going to go on ahead and write a workflow that deploys this code, that runs the unit tests, that does all the different, like we could build the pipeline parts before we ever built the actual app. And then we could start running our pipelines parts as we made commits to the code, and we could see how far we were getting, and we would be able to resolve those problems. Now this gives us a cool benefit. By the time we get done writing our code, we've actually created something that has a completely automatic path to go all the way to our production environment. So building the pipelines first could actually be of benefit because it's going to keep us from having to then stop and rethink everything later on. So keep that in mind for the way that you build code. A lot of the way you build code is actually more important to be thought of outside of the process of building the actual code. You want to think about why you're doing it certain ways and set yourself up for success so that you minimize the amount of time you spend reworking things just trying to get it out the door. Anyway, that's my PSA on planning ahead. Now let's go back over to our workflow and talk a little bit about some of the ways we might modify this. So let's say, for instance, that instead of just running PyTest, what we wanted was we were going to make a pre-build YAML. So this is what needs to happen before pre-deploy YAML. And so our pre-deploy YAML is going to be the steps that happen before we deploy. And that makes sense because we've got the pull request trigger on here. So when we're ready to PR to main, what are the things we should do before we allow deployment? And these are the things that happen not at the moment of deployment, but leading up to it. So we might have multiple jobs. And this would look something like this. So the first thing, of course, we should run our unit tests. So there are other things that we can do within our GitHub workspace to help our code get ready to be deployed. For example, we could come down here and we could add another step that maybe runs a dependency check. So we could do the OWASP dependency check. And as it turns out, there is a runner already created for this. So you come here and you do uses dependency check. Action main. And there you go. So now you've got the ability to add in any components that you wanted to use. And it's not limited to things like this that are specific one-line commands. You could build in, a custom script if you're going to deploy a database or something like that. Then whatever it takes to configure that database, you could actually load into your repository as a configuration script and then call that script from here. Once you've installed the database software, then you can follow it up with running the configuration that you want to set it up. You can even do other things like connect this to AWS. So if this was going to be a Lambda function, then you could connect this to your AWS account, and you could allow through GitHub Actions that you would deploy directly into Lambda. Now, there are a couple of things you want to keep in mind as you're doing GitHub Actions. First is that you don't want to store secrets directly in your workflows. Of course, those workflows are plain text that are stored within your Git repository. So anybody that gets access to the Git repo is going to have access to that secret. GitHub actually has a feature called GitHub Secrets where you can store the stuff and then make reference to it from an action. So go look up the docs about how to do that, because it's going to be really important for any sort of passwords or SSH keys or any kinds of other data that you want to have available, but you don't want to show to everyone. Make sure you're using good secrets management to protect those API keys and stuff. The other thing you want to keep in mind is that you're probably going to be able to do a bunch of this for free within the GitHub ecosystem, but if you don't keep your workflows efficient, you're going to get to the point where GitHub starts charging you for it. You're going to run out of that free space. So only run a workflow if it's absolutely necessary. So think of things like, you could theoretically set it up on every commit to run tests, but do you really want to do that? Or would you rather wait a little bit until you get to a merge, just to protect the amount of work that has to be done by GitHub to validate your code? So make sure that when you're setting up your workflows, you're being respectful of the space, and you consider that you're operating this in a shared space that could potentially cost you money. You get a ton of runs for free. I can't remember exactly what the specific settings are, but you can do a bunch of stuff for free within the GitHub space. But you will eventually run out. So if you're going to be using this heavily, and I personally believe you absolutely should be using this heavily, make sure that you're doing it in a way that's smart about your resources so that you don't run out. And just like that, you've got the foundation for automating your entire developer workflow with GitHub Actions. Now, as always, if you found today's adventure really useful or helpful in your journey, make sure you give me a thumbs up. Hit that like button so that I know this one hit the mark and you want more stuff like this. That's important to me, to be able to produce the right kind of content and give you the right kinds of adventures that help you on your journey. The other thing I want you to make sure you do is hit subscribe, because if you don't, you run the risk of missing next week's episode when it pops. And I want to make sure that we get to hang out together next week and build on this. Next week, we're actually going to explore the GitLab version of workflows and use their CI/CD products to see how they operate. So that's going to be an interesting thing. What's the same? What's different? What seems to work well? Which one's better? We get to look at some of that next week. So I can't wait to see you for the next adventure. We'll see you next time.